Well, now onwards to the calculation stuff. What is a solution? Now this may seem like a weird question, but a solution is when you can take the letters, which we call variables in an equation, and replace them with numbers, but it has to make the equation true. So one thing that we struggle with is this sign right here, equals. The equal sign. Okay, because the equal sign it's a conditional statement, meaning it could be true, which is what we want. It could be false. For example, I could make the statement 1 equals 2, and that's okay. It's just false. Is it okay for it to be false? It is. It's just we now know that it's false, okay? There are curriculums coming which will eventually say that's okay, but it's not okay. It's just false. So I can change this, though. I can say, well, what if I do 1 plus 1 equals 2? Now it's true. Now it is a true statement, right? Now, if we go back to equations with one variable, then if I were to say, look, let's say that it's x plus 1, then we would need a value to replace that x with to make this true, okay? And what we just saw, if you were to replace the x with 1, that would make a true statement. 1 plus 1 equals 2. Now, to take this a step further, what we're going to see, just like we saw on the grid, is we should expect to see two variables, x and y. Now, the question is, and this isn't really meant to be a trick question, but can we think of a value that would make this true? And one that comes to my mind is 0, 2. Replace the x with 0, replace the y with 2, true statement right there. Which means that on the graph, this point can go directly on the graph. Okay, well, what about 1, 1? Would that work? And the answer is yes. That would also make the equation true. Now, as much as you want me to, I'm not going to list all of the ordered pairs that would make this true, because there's an infinite number. Okay, so because there's an infinite number, it's nice to be able to use a graph to show that, because the graph will tell you any point on the graph should make the original equation true, even the fractional ones. So what we're going to see on the assignment as well is they may give us one value. They may say, hey, look at that equation right there. Well, what if x is 5? And then they're going to say, you solve for y, which, by the way, would be -3. I said that, and then I realized you probably don't care. But that would work, okay? So there are ways to do that. If we need, we may have to use some principles of equality. So let's go over principles of equality. This goes back to solving equations like 3x plus 5 equals 8. I just made that up. But principles of equality are used. You can see here, this is all abstract. This is very nerdy speak right here. So it's just saying if you have something, I'm going to go with the nerd stuff. If you have something that's equal to something else, you can add the same thing to both sides. You're still good, okay? Or you can subtract the same thing, or multiply the same thing, or divide the same thing. It's possible you've heard this, and this is principles of equality. Whatever you do to one side of the equation, you just have to do to the other side in order to maintain equality. If you don't, then you've changed the problem, and then what the crap. But we do these with purpose. For example, addition and subtraction. I've done better brackets, but that'll do. Addition or subtraction. We use addition or subtraction in order to force there to be zeros. We may see some examples for that, okay? But if I see a value that I don't want in an equation, I can zero it out with either addition or subtraction principles of equality. If I wanted to, I can also use multiplication or division. It's just if I use these two, then it means that I'm trying to make ones. Now, again, this is with purpose, right? So if I'm making a 1, it's really to make the coefficient a 1. Sal, what the crap is a coefficient? It's a number that's being multiplied by a letter. So let's go back to that theoretical equation, 3x plus 2 equals 8. I don't even know if that's the same one. But if I saw 3x, the coefficient of x is 3. In fact, let's make this a little bit more applicable, right? If I said 3x plus 2y equals 8, I now have two coefficients. I have a 3 coefficient and then a 2 coefficient. It just has to be a number that's being multiplied by a letter. That is it. Now it is a coefficient. But when we solve equations, generally speaking, we want it to be a 1, which we can force to happen with either multiplication or division. So here's some good news for you if you're going into some kind of math-related field, is if you can just understand that sometimes we can force the math to do what we want it to do, then there's no math you cannot do, okay? And sometimes it's making stuff be 0. Sometimes it's making it be a 1. Sometimes it's making them be common denominators. You see what I'm saying? You force that to happen. The problem is that a lot of students let the math take control of them, and it will ruin your life, just like it has many lives before. So we don't want that to happen, so we got our principles of equality. That's one tool we can use. And if we use it right, we can take advantage, and, well, not advantage. We can take control of the math and use it the way that we want to use it, okay? So complete the ordered pair so that it is a solution for the given linear equation. Fair enough. What I have right here is an x value, right? Because it's x, y. And so in the equation that's given, 2x plus 2y, which should equal 8, it's saying the x value is, well, it should be -2, right? So if I replace that x with -2, all I need to do is find the corresponding y value that still makes it a true statement, right? So right off the bat, I see I do have some distribution. Some people would say that's not distribution. Distribution is multiplication. So 2 times -2 would be -4. And then I can just kind of drop everything else. But now what I have is a new equation that I need to solve. To do this next part, I'm gonna use the principle of equality. Now you've noticed right here that I've drawn the line through the equal sign. That's because I know with principles of equality, if I do something to one side of that line, I have to show it on the other side. But what I would like right now from my principles of equality is to just be able to drop the 2y so that it's all by itself. I don't want that -4 with it. So how do I get rid of -4? Well, by get rid of, I mean make it a 0, just like we saw on that last slide. How do you make it -4 0? Just add 4. But once again, that's a principle of equality. So if you do it to one side, you just make sure you do it to the other side, okay? Well, what happens here? Well, -4 plus 4 is 0. That would be a positive 2y, which we've dropped. And then 8 plus 4 is 12. Well, here's the thing is in math, when we see a 0 like we see there, we get to ignore it, okay? So by ignore it, I mean we get to pretend like it never even existed, just like we would with people that are zeros, okay? Sorry, should I not have said that? Should I not have said that? My bad. In any case, so you guys are good. We're good. So I actually just show the 0 like this. Some students say I've circled those two. No, it's a 0, okay? But remember, in the end, what we really need is just y equals something, and then we get to replace it there. So 2y's is no good for us. So I'm going to force this, again, with the principle of equality to be a 1y. Well, how do you force a 2 to become a 1? Well, like we saw on the last slide, we can force any value to become a 1 with either multiplication or division principles of equality. I know that you can make any number become a 1 by dividing it by itself. So 2 divided by 2 is 1. And yes, that's kind of a funky one that I just put on there. But it's a slanted one. That's okay. And then we'd have to do it on the other side. So 12 divided by 2 is 6. I can even check. So I can go back to the original. I can say 2 times -2 is -4. 2 times 6 is 12. -4 plus 12 is actually 8. That checks off. And now I know that if I replace the y with 6 and the x with -2 in that equation, I now have a solution to that equation. And even to take that further, if I were to graph it, hopefully you don't have to graph stuff by hand, but if I were to graph it, I would put it at -2 and 1, 2, 3, 4, 5, 6. It would give me this point right there. -2, 6. Yeah, sorry, my lines are kind of jacked up. I did my best. Okay, but now that I have that point, I'm ready to graph the next point. Hopefully you are too. So let's go back to the original equation, and I'm running out of space here, but here we go. 2x plus 2y equals 8. Now again, I'm going to rush through this one just because we've seen it already. This is a y value that is given to us, -1, so I'm going to replace that y with -1. and I'm going to solve for the corresponding x value. So 2 times -1 is -2. You'll see that I've replaced that plus sign with now a -2 or -2 sign, and this is going to equal 8. So principles of equality now to solve. I'm going to add 2 to both sides. To zero that out, drop my 2x, which equals 10. And then the last thing I want here is a 1x. So I'm going to divide both sides by 2. And 10 divided by 2 is 5, which makes this ordered pair 5, -1. So that would be 1, that's x value 5. 1, 2, 3, 4, 5, and then a y value -1. That's this point. Now the beauty about lines that like this, it says linear. That tells us it's a straight line. So what I can do, because I'm a math nerd, because I don't think you guys would want to, but I'm going to do this. I want a different color though. Green, there we go. Oh crap. I can get those two. There we go. What you can do now is connect those 2 points together with a line, and every ordered pair, we're pretending like I did this, I drew it very well. But every point on that line would make the original equation true, every single ordered pair, including the fractional ones. In fact, you notice I put arrows on the end. That means it extends forever. So you could get into some extraordinarily large numbers, but you can also get some extraordinarily small numbers as well. This one, determine whether these ordered pairs are solutions for this equation. No problem. So once again, we'll start with this one. We got x value of -1, y value -0.5. So, oh good, I got my trusty calculator. Our equation is -2x plus 2y equals 1. Now, like I said, I'm going to do this calculation, but the calculator is going to do the heavy lifting for me right here. So I'm not going to do it order of operations as much as you want me to. Why? Because the calculator knows the order of operations. How freaking awesome, right? So I'm going to take the x, and I'm going to replace it with -1. Tried to make them red. And then the y value, I'm going to replace with that decimal, -0.5. Try to give yourself more space. Now it's asking, is it the solution, right? So I'm going to put a question mark over the equal sign. If it becomes true, then it is the solution. So I'm going to type this in. -2 times -1 plus 2 times -0.5. Now, if I push enter and I see that it does actually equal 1, then I know that it is a solution and it would be true because it would be a true statement. If it gives me anything else, it is not a solution. I push enter, and all this garbage right here is actually 1, and 1 does equal 1. Hopefully we know that's true. That is true. Yeah, so I guess it was asking, is it determine whether it is true? I feel like I should put yes, but I don't know if I should. I think they communicate the same thing, so. But we'll get both. Okay, but again, notice I did not do order of operations here because the calculator did it for me. Just make sure you're typing it in right. I say that more for my benefit than yours. So next one, -2x, same equation by the way, -2x plus 2y equals 1. But now the x value is a +1, and then the y value, which again it's just shown in the ordered pair, is 2.5. My instincts tell me no, but let's just make sure with the calculator. -2 times 1 plus 2, I almost typed that in wrong, times 2.5, positive enter, and all this stuff right here just gave me a 3. So as I'm checking this, right, which I've just done, I found that 3 equals 1. That's false. So I guess no or false, either one.